In this video, we are going to see electric flux. First, we see the definition of electric flux. So, this is the uniform electric field region. In this region, a particular area is kept normal to the electric field direction. That is perpendicular to the electric field direction. So, the number of electric field lines crossing this given area kept normal to the electric field lines is called electric flux. Its unit is Newton meter square per coulomb. It is a scalar quantity, so its value may be negative or positive. Electric flux is represented by delta pi E is equal to E into delta S. The area vector, that is delta S vector, is parallel to this electric field vector. Then electric flux value is maximum, that is E into delta S. Suppose the area vector is perpendicular to this electric field vector. Electric flux is 0 because no electric field lines are passing through this area. Next, we see how to take components in electric flux. Here area vector, that is delta S vector, is inclined with an angle of theta from the electric field vector. So this term, that is delta S vector, is considered as a horizontal component because it is involved in formation of theta. Horizontal component is always represented in terms of cos theta. Here we are taking component for electric field vector. So horizontal component is equal to E cos theta. So that vertical component is equal to E sin theta. Here also the opposite direction is also vertical component, but in opposite direction. This is also E sin theta. Here the vertical component is equal to 0 because same magnitude but opposite direction. So sum of the vertical component is equal to 0. So for E vector we have to consider only the horizontal component, that is E cos theta. We know that the electric flux delta pi is equal to E vector dot delta S vector. For E vector, we can consider E cos theta. For delta S vector is equal to delta S into n cap, where n cap is the unit vector. So pi is equal to E cos theta into delta S. Finally, we can say delta pi is equal to E delta S cos theta. That's why when area vector is parallel with the electric field vector, electric flux is maximum because theta is equal to 0, cos 0 is equal to 1. So delta pi E, that is electric flux, is equal to E into delta S. In the same way, when an area vector is perpendicular to this electric field vector, electric flux is minimum because theta is equal to 90 degree, cos 90 is equal to 0. So that electric flux, that is delta pi, is equal to 0.